All right, here we go. This is learning target 1.3.2. The focus is on writing linear functions given scenarios. So when before we get into that, let's revisit some stuff from 131, so our first 3.0 target. It says, what is the equation of the graph to the right? So remember, when we're writing linear functions, we think slope-intercept form, which if you recall is y equals mx plus b. So we need a slope and y-intercept. So that y-intercept is where it touches the y-axis. So in this case, our b value is going to be 5. Our m is our slope. So I see another point here. So as we look here, we're going up 1, 2, 3. So our rise is 3. Our run is 1. And I am checking the scales to make sure it's going by 1 so that I don't make that mistake in mixing those up. So our rise over run would be 3 over 1, so our slope would just be 3. So we have y equals 3x plus 5. Next, it says write a scenario about how many math problems you solve. So when we're writing scenarios, remember we want to use the y-intercept and use the slope. With the y-intercept, we use words like already have, started with. With the slope, you use words like every or per. So we could say something like, I have already done 5 math problems and plan to do 3 per hour. So when you're thinking about that slope, which is 3 here, units of time are usually helpful. Okay. So why don't you try number 2 here, write a scenario about how many friends you have for the same equation. Pause the video, quick do that. Okay, write a scenario about how many friends you have. So you could say very similarly, I already have 5 friends. So again, using that y-intercept with words like already have, and hope to gain 3 every year. So that slope, using words like every, and it's some sort of time reference. Okay. So this is 131 review. Let's start with 1.3.2. And you'll see some similarities here. Okay, so for 1.3.2. So for these, and really any other problem where you're writing linear functions, to use y equals mx plus b, to use slope-intercept form, you need to figure out what's your m and what's your b. What is your slope and what is your y-intercept? So let's read the question here. It says, Kirk has been solving math problems like crazy today. After 3 minutes, he had solved 20 math problems. Later on in the day, after 8 minutes, he had solved 50 problems. Write and graph a linear function which depicts Kirk's problem solved for the day. Okay. So there's a lot going on here. I'm noticing it says after 3 minutes, he solved 20 problems, and after 8 minutes, he solved 50. So those are pretty key in that 3 minutes, 8 minutes, 20 problems, 50 problems. So it looks like we have something that's increasing. So 3 minutes, 20, 8 minutes, 50. So these, to me, are points. 320 and 850. So our goal is to write and graph a linear function. So the first thing that we do here is, if we're writing these in steps, is we get our points. And our goal is to write and graph a linear function. So if we're writing a linear function, we need a slope and y-intercept. So we have 2 points, neither of which are the y-intercept because neither has an x value of 0. But with 2 points, we can find the slope. So you may recall slope formula. So I'll write that here. This was the first thing we did. Slope formula, y2 minus y1 over x2 minus x1. So what we can do is we can find the slope now using those 2 points, using our y2 minus y1 over x2 minus x1. So for us to find the slope, or for us to find m, we take y2 is 50 minus y1 is 20 over x2 is 8 minus x1 is 3. 50 minus 20 is 30. 8 minus 3 is 5. Now we simplify. 30 divided by 5, well, that is 6. So we have an m value of 6. So if we're writing this in slope-intercept form, we have y equals m x plus b. So we're still missing that b value. You may recall from 1.2.3 the problem with parallel and perpendicular lines. At this point, all we need to figure out is b, and we can use one of these points to figure out what b is. And it doesn't matter which one you pick. So notice these points are x and y values, so what we can do is we can plug in, for example, let's take this first point, where 3 is x and 20 is y. So we can plug those in for x and y into this problem and solve for b. So what we're going to do, or what our second step is, plug in a point and solve for b. So 3 times 6 is 18. Subtract 18 from both sides, and we get b is 20. b is 2, sorry. So we have an m of 6, we have a b of 2. So our function then, in slope-intercept form, would be y equals 6x plus 2. So we have our function. Next we need to graph this linear function. So we have a coordinate plane here. As we're graphing y equals 6x plus 2, the first thing we're going to do is we're going to label our axes. So you'll notice here, as we think about our axes, we have to think about what x and y represent. So up here our points are 320 and 850, where our x values represent minutes, our y values represent number of math problems. So in this case, the x-axis would be minutes, and the y-axis would be math problems. We want to make sure that we can plot this line as well as fit these points. So we have a point at 320 and a point at 850. So as I think about my x-axis, it needs to go at least up to 8 because that's my highest x value. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8. So this is going to work. We can just go by ones. So we'll go all the way up to 11. For our y-axis, it's got to cover from 20 to 50. So it's got to get all the way up to 50. So as I look at this, if I go by ones, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11's not going to get me to 50. So we have to scale it by something else. So why don't we try 5s? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Okay, so 5s will work. We're going to go by 5s here. Okay. And you don't have to fill in the entire axis. As long as you fill in the first few to show me what it's going by, that's good enough for me. So now let's plot what we have. So we have 2 points. We have a point at 3, 2. Or I guess so. We've labeled the axis, and now we plot our function. So we have a point at 3, 2. 320. So x value of 3, y value of 20. We have a point at 850, so x value of 8, y value of 50. So there are 2 points. In addition to that, from our line, we know the y-intercept is 2. So we can get another point right there. It's pretty close to 0. Now we have 3 points on this. You could go ahead and use that slope, go up 6 over 1 if you want to. But we have 3 points, and that should be enough for us to plot our function. Okay. So, long problem here, but so let's talk through what we did. So you had to first figure out what your points were given the problem. So our points were 320 and 850. From there, we found the slope using the slope formula. So y2 minus y1 over x2 minus x1 to get 6. Next, we plugged in 6 into slope-intercept form along with one of our points. So you could have picked the other one, you'll get the same answer, as long as you make sure to plug in x and y correctly. And we got 2 for b. From there, we had our slope and y-intercept, so we could write our function. Now we just need a graph. So to graph, we needed to label our axes first, both scaling them and calling them something. So minutes and math problems we got from the x and y values at these points. So x, y. Then we plotted our function, we plotted the 2 points, and then plotted our y-intercept from our line, and drew what we had. And that's it. Long problem, I know, but they're all things that we've done before. Things you've seen. It's just putting a lot of stuff together. Okay. All right. We'll talk through one more problem together, and then I want you to try one on your own. So here we have, it says, Lindsay is spiking Layla in the face like crazy. After 2 minutes, she has spiked her 12 times. Later on, she has spiked her 36 times after 10 minutes. Write a linear function and graph Lindsay's crazy spiking. So again, we're writing a function, we're graphing. So to start off, step 1, remember, was to find 2 points. So as we look here, it says after 2 minutes, she spiked her 12 times. Later on, she spiked her 36 times after 10 minutes. So our x and y values here are minutes and times spiked. Generally speaking, if it's anything related to time, we always use that for our x value. That's just general convention. So if we take this first point, we have 2 minutes, 12 spikes. So we'll say that's 212. We have next 10 minutes, 36 spikes. So those are our 2 points. All right, we've got our 2 points. Now we need to get through the process of writing a linear function. So we start by figuring out what's our slope. So our slope, remember, we do y2 minus y1. So y2, which is 36, minus y1, which is 12, over x2 minus x1, 10 minus 2. 36 minus 12 is 24. 10 minus 2 is 8. 24 divided by 8, well, that's 3. So we have our slope. Now we need the y-intercept to write our function. So in slope-intercept form, y equals mx plus b, we have y equals 3x plus b at this point. To figure out our b value, we need to plug in one of our points. So let's just choose the first because the numbers are smaller. So we plug in 2 for x. We plug in 12 for y, because it's x and then y, and then solve. So 3 times 2 is 6. Subtract 6 from both sides. 12 minus 6 is also 6. So we get a b value of 6. So we have m is 3, b is 6. So our function in slope-intercept form would be y equals mx plus b, 3x plus 6. Okay. So we've done this part. We've written a linear function. Now we need to graph. So for us to graph, we need to label our axes. So again here, our x value is in terms of time, so this is minutes. Our y value is, it just says times, but we want to be more specific than that. So we'll say times spiked, so we know what that means. Now we need to scale out our axes. So our x value has to go up to 10. It's the same graph as before, so we should be able to just go by ones again. Yep, that works for us. Next, we have 12 and 36. So we can't go by ones. It only goes up to 11. 2s would get us to 22, 3s would get us to 33, 4s would probably work, 5s would work, 10s would work. Whatever you want to do, it's up to you. I'm going to go by 5s because I like those round numbers. So 5, 10, 15, 20, 25, 30, 35, 40. Okay, now let's plot the points that we have. We have a point at 212, so 2x, 12. So 12 is more than 10, less than 15. So somewhere in the middle, pretty closer to 10 though. Next we have 10, 36, so x of 10, y of 36, so just above that 35 marker. So we plotted those 2 points. We can also plot that y-intercept where it crosses the y-axis from our line at 6. So we've got 3 points. That should be sufficient for us to connect our dots, draw our line. Okay. All right, almost done. We've just got one more. Next problem here. It says you decide to take a road trip to visit a friend. Over your first 4 hours of driving, you have driven 340 miles. 2 hours later, you notice you have driven 120 more miles. Write a linear function which shows your total distance. So I'm going to try have you do this on your own, but before you do that, I want to just talk about this first step with these points, because this one is a little different. So as we look at this first point, it says over your first 4 hours of driving, you've driven 340 miles. So 4 hours, 340 miles. Next, it says 2 hours later, you notice you've driven 120 more miles. This point is not going to be 120. Not 120, even though it says 2 hours, 120 miles. The key is this later and more. So it's giving you a point in the course of this trip. It's saying 2 hours later, so 2 hours more than 4. So 2 hours more than 4 would be 6. You've driven 120 more miles, 120 more than 340. So that would be 460. So notice we had to add that 2 to 4 and add that 120 to 340 to get these points. So those keywords are important in that they're talking about adding those on to what was previously stated. Okay. So pause the video, try the rest of this on your own, and then we'll walk through it together. Okay. Second step, we need our slope. We're back, so y2 minus y1 over x2 minus x1. So 120 over 2, which is 60. Next, we need that y-intercept. So we have our slope. We just need that b value. So we plug in one of our points. So let's go for 340 and 4, because those numbers are smaller. 6 times 4 is 240. Subtract 140 from both sides, we get b equals 100. So our function in slope-intercept form would be y equals 60x plus 100. Y equals mx plus b. Now let's graph, because we are going to graph. This one, however, it says just write a linear function, so I guess we didn't technically have to graph. But let's just do it for practice. So our x value here for these points, so 4 and 6, represents hours of driving. Our y value, 340 and 460, those represent miles driven. So we need to include at least 4 and 6 on our x, so again, it's nice for us, we can just go by ones. For our y values, we need to get up to 340 or 460. Whew. So let's go by hundreds here. I just know that'll do it for us. You could do 50s, that would probably work. It's up to you what you want to do. Hundreds just seem pretty easy for me. So we plot these points. We have a point at 4, 340. So that's somewhere right in here. We have a point at 6, 460. So that's about there. And then our y-intercept is at 100. So there we go. You'll notice the y-intercept ends up being 100. If you use this point as like 120, Notice that doesn't really match up. It's going at like 200 there. So if you use that point at 2120, it doesn't work out for you, in that sometimes you have these problems where you've already driven a total number of miles. You have a starting point, and this is just talking about like your second day or something. You need to take that into consideration with the way that it's written. Okay. So that is it for 132. I know these problems are pretty long, but please remember, everything that we do in this problem is something you've done before. It's just a matter of combining things, putting things together to make things work out.